Hello friends, welcome to RDIS, and today we are going to talk about another topic which is very interesting, and the topic is Cosmic Infrared Background Experiment 2 or CIBER 2. Before starting the topic, let us discuss a question, and the question is with reference to the CIBER 2 mission, consider the following statements. So the statement number 1 is that it's an ambitious mission to physically count each star in the universe. And the second option is the mission is a joint initiative of NASA as well as European Space Agency. So these are the four options. You have to identify the correct option. You can comment the correct option in the comment section below. I hope by the end of the video you will be able to answer the question correctly. So let's move ahead and see why was this in news. So NASA and not European Space Agency has funded this CIBER 2 sounding rockets launch window that will be open from White Sands missile range in New Mexico, USA. So what is the aim of this CIBER 2 mission? It basically aims at counting the extra stars that may have been missed in the stellar head counts. So here the term sounding rockets. So what does this sounding rockets means? So sounding rocket take their name from the word that is to sound, which means to take measurements. So since 1959, NASA has used sounding rockets to test instruments used on satellites which provide information about sun, stars, galaxies, or the Earth's atmosphere. Moving ahead, let us see till now how were we counting the number of stars. So firstly I want to ask you, can you count the number of stars while looking at the sky? Certainly not. Now, or you can also say, okay, I can count, but wait here. Look at the same sky using a telescope. You'll see that the number of stars that you were able to watch from your naked eye were lesser than when you see it from the telescope. Now, this is a picture taken by the Hubble telescope. This Hubble telescope is present outside the Earth's atmosphere in the space. So, can you count the number of stars in this picture? Certainly not. There are other telescopes also, like the Spitzer telescope of NASA, which have also taken certain pictures. So that clearly shows that the number of stars that we see in the night sky is not the same that we see in the universe. So let us move ahead and see that how are these stars estimated. So definitely you cannot give the exact number, so the estimation is only possible. So as far as estimation is concerned, so European Space Agency used this infrared space observatory, that is Herschel, to count the number of galaxies in the infrared and measured their luminosity previously. So according to the European Space Agency, there are about 100,000 million stars in the Milky Way alone. So as we know that in this topic we are talking about CIBER 2. So this means that there was a CIBER 1 mission also. That's why we are talking about this CIBER 2, because there was CIBER 1 mission also. So in CIBER 1 mission, we also tried to count the number of stars, but this time the CIBER 2 mission is much more advanced in the terms of the instruments the scientists are using. So let us see why are scientists so keen to count the number of stars. Actually, before that we were counting the stars from the Earth itself, from the Earth's surface itself. But what does this NASA Spitzer space telescope hinted was that the stars hiding in the plain sight are actually more than what the scientists expected. Consider this as the surface of Earth, and these are the stars. These stars are millions and trillions of light years away. So when these stars emit light and they reach the surface of Earth, they have to go for multiple reflection, and even sometimes absorption also. So during the process, the light that is emitted gets fainter and fainter. So when this light gets fainted, the amount of light that reaches our eyes is certainly very less. So, what does the scientist expect from this Cyber 2 mission? The scientists not only expect to count the number of stars, but also this mission can give a hint about the ancient galaxies that might have been present, and also about the dying black holes as well. Moving ahead, let us see what does this term extra galactic background lights or EBL means. So why are we reading this term is because in this experiment the scientists are concerned about a portion of extragalactic in background light that is in the range of infrared, cosmic infrared background. So first let us see what does the term extragalactic means. Extragalactic is nothing but something that is outside our Milky Way galaxy, outside our Milky Way. So these outside our Milky Way galaxy stars have some background lights. So these background lights is nothing but a packet of photons that travel through the space and reach our eyes. So what does this spectrum, this photo that it's here, what does this spectrum means? So when we see a light has several components, and we have divided these components into the UV rays, the visible or the optical rays, or infrared rays and microwave rays. So we have divided the light component into various divisions, and these divisions are basically with respect to the energy, or you can say the wavelength or the frequency. So when we talk about the extragalactic background lights, galactic background lights is the background glow of the collective photons. So Cyber 2 mission, the first Cyber mission, actually witnessed that has UV rays as well as optical rays. And when we talk about the Cyber 2 mission, it is basically about the infrared rays. So Cyber 2 mission, which talks about the cosmic infrared background, we are particularly interested in this infrared ray because most common stars actually, uh, like the M and the K dwarfs, actually emit the cosmic infrared rays. So moving ahead, let us see what's in the mission. So the first cyber mission, which began in 2009, has paved way for the another mission. So Cyber 2 mission, the Cyber 2 instrument that has been launched, has a sounding rocket and a small suborbital rocket. So this rocket will actually surpass the Earth's atmosphere and will reach in the space where it will survey a patch roughly about 4 squares degree. This small patch, 4 square degree small patch, has dozens of galaxies. So you can see, when there are dozens of galaxies, how can it be possible to physically count each star? So what will the instrument detect is the extragalactic background light. So when we get this extragalactic background light, scientists will then focus on only the cosmic infrared background. So scientists will actually not focus upon the UV, the visible light component of the EBL, the extragalactic background light, and will only focus on the infrared part of it. So after focusing on this infrared part, the scientist will estimate as to how many number of stars can be present in that very patch, and then by the process of integration, the scientist can estimate the number of stars in the sky. So as far as this topic is concerned, this topic is important for your prelims perspective. UPSC can also ask this topic in your mains paper. I hope you like the video. Thank you for watching it, and please like, share and subscribe.